lightning speeds, and do this while conserving energy. Let's dive a little deeper into these advantages. Firstly, AI processors are incredibly efficient at handling large volumes of data. They are built with parallel processing capability, enabling them to handle multiple tasks simultaneously. This is particularly significant in today's data-driven world where we are constantly generating and analyzing vast amounts of information. Secondly, speed is another major advantage. AI processes are designed to perform complex computations at a rapid pace, which is essential in fields like machine learning and deep learning. They can process data and run algorithms much faster than traditional CPUs, resulting in quicker decision-making and faster response times. Then there's the energy-saving attribute. AI processors are designed to be more energy efficient than traditional CPUs, which is crucial as we strive towards a more sustainable future. They consume less power while delivering high performance, which not only reduces energy costs but also minimizes the impact on the environment. These advantages are driving the adoption of AI processors across various industries. Tech giants are already leveraging them to enhance their products and services. In healthcare, AI processors are being used to analyze patient data and deliver personalized care. The automotive industry is using them to power self-driving cars. AI processors are not just changing the way we work today, but they also hold the potential to transform the future of computing hardware. They can make our devices smarter, our systems faster, and our technology more efficient. While AI processors have notable advantages, it's not to say that traditional CPUs will become obsolete. Both have their strengths and will likely continue to coexist, each serving their unique purposes in the world of computing. The future of computing hardware may not be a question of replacement, but rather one of integration and collaboration.